So in this video, I'm going to talk about acids and bases and give a brief introduction to that. So there are a few definitions for acid and bases. So there's a Bronsted acid and base. So a Bronsted acid is any molecule with hydrogen that can be donated. In contrast, the Bronsted base is a molecule that accepts hydrogen. And so an acid and base is not going to really change. There are just different definitions for it. And there's also a Lewis definition. So a Lewis acid is essentially the opposite. So if you donate a hydrogen, you're gonna accept an electron. It's kind of easy to think about it like that. So a Lewis acid is an electron acceptor, and a Lewis base is an electron donor. And so for an acid, there's going to be an equilibrium. And so we typically use the acidity constant. So for example, you have Ka equals concentration of A minus times the concentration of hydrogens over the acid, concentration of the acid. So in the numerator, it's essentially what's being described as the acid donating the hydrogen. So for example, if you have a higher concentration of hydrogens, then it's going to favor, the equilibrium is going to favor donating hydrogens. And so as a result, if you have large Ka, that means that it's a strong acid. While small Ka is a weak acid. And so the common way people describe the strength of an acid is actually based on pKa. And so pKa is equal to the negative logarithm of Ka. And so essentially what you need to take out of that is small pKa is a strong acid. And so let's kind of do an example and summarize it up. So overall, strong acids have low pKa's and high Ka values. Strong acids also have weak conjugate bases. So weak conjugate bases. And what that means is when you're at equilibrium, say you have a CH3 minus and then an H2O is at equilibrium with a CH4 and an OH minus. So you have CH3 as a base, water acts as an acid, and then CH4 is a conjugate acid of CH3 minus, and OH minus is a conjugate base of H2O. So essentially on each side of the equilibrium arrow you have a base and an acid. And the thing that acts as a base on the other side of the arrow becomes a conjugate acid. And so strong acids have weak conjugate bases. So what that means is that, for example, the pKa of water is 15.7 and the pKa of CH4 is around 50. So the equilibrium is going to lie far to the right because water is a stronger acid and more likely to donate electrons than CH4. And also strong acids have stable conjugate bases. And what that means is essentially if you have a stable conjugate base, the molecule will more likely be formed because it's very stable. So that's a good way to think about it. And so, for example, if you look at this equilibrium, CH3 minus is very unstable compared to OH minus. And so that's why the equilibrium will favor more to the right as well. Because OH is more stable, it will more likely be made. And in the next video, I'm going to talk about the factors that affect acidity.